See the effect of a catalyst. A catalyst is going to provide an alternative pathway, an alternative route with a lower activation energy. A catalyst will not lower the activation energy. I know this was part of the IGCSE definition, but for DP, you have to know that a catalyst will not lower the activation energy, but it will only provide an alternative route with a lower activation energy. Now, a catalyst will not undergo any chemical change itself. So at the end of the reaction, the catalyst remains chemically unchanged, and the catalyst will allow a larger number of particles to have kinetic energy greater than the activation energy without having to increase the temperature. So if you have the reactants here and you have the products here, so you can see that 2 is the activation energy without catalyst, which is higher, and when you add a catalyst, it provides an alternative pathway with a lower activation energy. So in red you can see the new pathway, and 1 corresponds to the activation energy with catalyst, and as you can see, this is lower. So as you can see, a catalyst is going to affect the energy of the reaction. Now, if we show this on a Boltzmann distribution curve, we can see that the energy, the activation energy with catalyst is lower than when there is no catalyst. So this can be shown on a Maxwell-Boltzmann distribution curve here. So you could show this as EA1 without catalyst and EA2 with the catalyst. So EA2 is lower than EA1. And so you can see the number of particles having energy greater than activation energy increases in the presence of the catalyst. So this area over here is greater. Actually, it should be like the whole area over here. This is greater than the area that is shown in gray over here. And a catalyst, like I mentioned before, increases rate by providing an alternative pathway with lower activation energy. And normally in industries, catalysts are used to reduce energy costs. Without catalyst, reaction would proceed very slowly or would need very high temperature, and it costs a lot to maintain high temperatures. You have to heat, you have to use fuel, and catalysts reduce the negative impacts of chemical processes on the environment because the catalyst is used over and over again without itself being chemically altered. It's important in the aspect of green chemistry. Green chemistry is, it aims to reduce the number of waste substances. So when we have a reaction, we use all the reactants instead of discarding some. So in this aspect, catalysts are effective because you need a small amount of it and you can reuse it, and they do not contribute to chemical waste. So it increases the atom economy. Now, enzymes are biological catalysts, and they work in specific chemical reactions. So depending on the reaction, you have specific enzymes that will catalyze the reactions. And normally, enzymes are more effective than inorganic catalysts. They are also very specific, which means that they catalyze only one particular reaction, and due to that specificity, enzymes do not produce byproducts. And enzymes work at very mild conditions. That is, normally it has an optimum temperature of 35 to 40 degrees Celsius, and the pH is also specific to the type of enzyme, to the type of reaction. So with this, we finish the first part of topic 6.